Okay, today we are in section 9.5. We are going to be graphing sine and cosine curves. So we're going to start with the parent graphs of sine of x and cosine of x. So this is going to be y equals sine of x. And I tend to graph these always the same, and I expect you to graph them somewhat similarly to this. It's very simple to do it this way. I like to see two full periods in one graph. And so we're going to start with um, our pi, 2 pi, negative pi, and negative 2 pi. And then I'm not going to label the pi halves, but I'm going to put those tick marks in there. Because what tends to happen is the x-axis just gets all glommed up with labels for what things are. But as long as you have pi and 2 pi labeled, then we understand that the other marks are pi halves. All right, so sine of x is 0 on the multiples of pi. So I'm going to start by putting those points in. And then at pi halves, sine is 1. 3 pi halves, sine is negative 1. And so here's the right portion of my graph. And then I'm going to go ahead and go backwards a full rotation as well and get the same exact graph. Again, we know that sine and cosine are periodic. This graph repeats over and over and over again, and I'm showing you two full cycles of it. All right, and now let's do cosine. And we're going to do this the same way. Our amplitude, our extreme values are 1 and negative 1. I'm going to label what happens. I'm going to label on the x-axis pi, 2 pi, negative pi, and negative 2 pi. And then I'm just going to simply put in tick marks for the halves. Now, in cosine, we are 0 on the odd multiples of pi halves at the angles that land along the y-axis when you are thinking about angles on the xy axis. And then the cosine of 0 is 1, pi negative 1, and 2 pi is 1. And so here's one cycle. And then negative pi, negative 1, and 2 pi is 1 again. And here's our second cycle. So these bend down. Make sure you don't draw them as arrows that go up, because that's not what happens, right? They don't go up forever after this. They turn around and come back down. And these are our parent functions, and I will start by graphing these pretty much every single time. Okay, so the big lesson that we're going to do is we're going to talk about the transformations of these original sine and cosine graphs. So I have here two general formulas for sine of x and cosine of x. So this is how you can modify the sine and cosine graphs. One way you can modify it is to adjust the amplitude A. In our original graphs, we had an amplitude of 1. But anytime you would multiply something in front of the sine or the cosine, your amplitude will be that high. So your amplitude will be magnified by that amount. And then the second thing we're going to look at changing is the period. So the period is affected by the multiple of the x, b. Okay, and we have a formula for period. Period equals 2 pi over b, and you do need to know that. Okay, and now I have three basic examples here to determine the amplitude and the period. So on this first example here, let's call this number 1, the amplitude would be this number in front of the sine 2. Then my period is going to equal 2 pi divided by the number b in front of the x2. So in this case, the period is pi. All right, now on number 2 here, what is my amplitude? Well, the amplitude is always going to be positive. So even though this is a negative 2, I'm still going to say that the amplitude is 2 because you want to use the absolute value of A. So maybe I should modify this and say the amplitude is actually the absolute value of A. That negative matters. That will reflect our graph over the x-axis, but it doesn't change the amplitude. Okay, because the amplitude is just the magnitude of what's in front of it. Okay, so the period is going to be 2 pi divided by this time pi. So now my period is 2. The period tells you how long a cycle is. So normally sine and cosine have a period of 2 pi. If you look at this, b is 1, and so my period is 2 pi over 1, or 2 pi. And so the length of one complete cycle is 2 pi. And then that just repeats over and over and over again. Okay. And then I'm going to let you guys work on number 3. Moving on. Now, we're going to adjust the amplitude and the periods of my original sine and cosine graphs, and we're going to graph them. Okay, so it's good that you can find the amplitude and the period, but now I want you to graph with a different amplitude and a different period. Now, we're not going to do much different here. We really don't. I have a really good trick for changing the period. So I'm going to start this the way I always start it, by labeling my x-axis with pi, 2 pi, negative pi, and negative 2 pi, and go ahead and put in tick marks for the halves. I am going to change my 1 and my negative 1. I'm going to look at the amplitude, and I'm going to change to that number, 2 and negative 2. Then I'm going to go ahead and graph just like normal. This is a cosine graph, and so I'm 0 at the half marks. Okay, and I am not going to graph exactly just like normal. I do notice that I have a reflection. So I'm going to go ahead and graph the reflection now. I'm going to reflect over the y-axis. So at x equals 0, instead of going up to 1, I'm now going to go down to negative 1. Well, really negative 2 because my amplitude changed. And then at pi, I will have a value of positive 2. I don't want to graph that in green. And at negative pi and 2 pi, I'm going to graph it in black. Okay, so I have already accounted for the negative sign and the amplitude. But what I haven't done at all is adjust for the period, right? And I do have a b value that's not 1 here, so my period will change. What my period will change to is it will take the original 2 pi period, and I'm going to divide by pi. And so I get a period of 2. The action of dividing by pi is how we adjust the period. And so instead of adjusting the picture of my graph, I am going to adjust the period, but I'm going to do that by adjusting the scale of my axes instead. I'm going to divide all of these values by pi, because that's how the period will adjust. You take your original period and you divide it by pi. So I take my original graph and then I divide my axes by pi, and that will adjust for it accordingly. And so when we simplify this pi over pi, that is 1. Let's do this in blue. And this 2 pi over pi is just 2. And then I have negative pi and negative 2. Or sorry, negative 1 and negative 2. And I drop my negative 2 here. And now I have adjusted for the period as well. But it was much easier to just adjust the scale of the axes rather than to shrink or stretch the entire graph. Okay, so let's do number, so this would be, let's call that A. And this is B. All right, so now, same thing except we have sine. So pi, 2 pi, negative pi, negative 2 pi. And I'm going to put in marks at the halves. And my amplitude, let's go ahead and adjust that now to 5 and negative 5. Okay. And then the sine is 0 on the halves, or sorry, on the multiples of pi. So I put in the zeros right there with the multiples of pi. And then I am 1 and negative 1 at the multiples of pi halves, odd multiples of pi halves. Okay. So that's my sine graph with the amplitude adjusted for, but I need to worry about this period. So now my period is going to change. It will be 2 pi divided by 3 halves. Now, when you divide by a fraction, there's a much simpler way of doing that. Instead, we should multiply by the reciprocal. To multiply by the reciprocal, we flip the bottom fraction and multiply by that. So I was dividing by 3 halves. That's the same as multiplying by 2/3. And so I'm going to adjust my x-axis by multiplying by 2/3. So 2 pi times 2/3 was 4 pi thirds. And then I have negative 2 pi thirds and negative 4 pi thirds. And now I've adjusted for the period as well. And it's as simple as that. Okay. Now what's actually harder is doing the vertical and the horizontal translations. because you do have to redraw your graph on these. There's no getting around it. I mean, last time I was simple. I just adjusted the axes, but I never redrew the sine and cosine graphs. However, if you're shifting up and down or left and right, then you have to redraw your graph, unfortunately. Okay, so we're going to start with the theory here. The C and the D are the shifts. D is the vertical shift. You will go up or down an amount D. And then this C is called the phase shift. That's also called the phase shift. And that will shift you left and right. Now remember, it's happening inside the parentheses with the X, so it's the opposite direction of what you think. If it has a +2, you're actually going to be moving left. Okay? The other thing that adjusts is we still have to do that dividing by B thing, where you adjust the period. So the phase shift is -C over B. That's a formula that you might have remembered from trig, but we would move left or right that amount. So let's do some examples here. Okay, I'm going to still start the way I normally start. Pi, 2 pi, marks at the halves, -pi, -2 pi, marks at the halves. The amplitude here is still, I didn't change the amplitude, so it's 1 and -1. Okay, but I did change, oh, and this is sine, so let's put our zeros in at the halves. And, oh, that's cosine. Keep doing things wrong. Okay, sine is 0 on the pi's. And we're 1 on the pi halves. All right, now I do realize, I do see that there's a phase shift, so I'm going to go ahead and graph this original one with a dotted line. Okay, so that's just my regular old sine graph. Let's first adjust for the period. We're going to divide by pi. So this 2 pi is now 2, and the pi is now 1, and -1, and -2. Oops. 1, -1, and -2. Okay, so I've already done that. Now let's do the phase shift. So I'm going to move left, okay? Now this said pi over 2, but I'm going to actually have pi over 2 over the original b value pi. So I'm going to move left a half. I will move left a half here. And so I've already adjusted for the dividing by pi as well. So this point right here at 2, 0 will move left a half, and it will be at 1 1/2, 0. And then the other 0 here that was at 1 will adjust to a half left. All right, so I'm going to move all of my values left a half. And so this original cycle that was on the positive x-axis over here between 0 and 2 pi shifted left a half. Okay, and then over here we have each of these points moving left a half as well. And this is my new graph, and the blue graph is the final answer. Okay, let's do it again. We're going to do it with cosine this time for letter B. All right, so graph just like normal. Pi, 2 pi, ticks at the halves. -pi, -2 pi. Tick marks at the halves. Put in your amplitude, and then stick in your zeros. Cosine is 0 at the odd multiples of pi halves, and 1 everywhere else. 1 or -1, we alternate. Okay, then go ahead and again put in your graph, but dot it, because I can see that I'm going to have to shift. I have to shift this one. This time I'm going to shift it to the right. Okay, so this graph has a period change as well. Here my B is 2. So I have to divide everybody by 2 to adjust for this period change. All right, and let's just write -2 pi over 2 as -pi, and 2 pi over 2 as pi. Okay, and now let's do our phase shift. So our phase shift as a horizontal shift, are we going to go right or left? Well, it's always the opposite of what it looks like whenever you're inside the parentheses. So we're going to go right pi, and then don't forget to divide by your b. So we're going to go right pi halves. So I'm going to take, and notice pi halves this time is one of my original full ticks. So it's actually 2 ticks on this graph. So I'm going to move this point here at 0, 0, 1, right to a half 1, pi halves 1. So that moved over to there. And this 0 is going to move over to that 0. And then this -1 point will move over, over here to pi. And then this 0 is going to go over here. And I kind of ran out of room there. So let's draw this part here. And then this 0 moved over to this 0. The negative pi halves -1 moved to 0, -1. And we're just moving each one. Did I do that one right? So this 0 went here. I went a little bit too far left there. This moves, pi halves. Yeah, here we go. And then this last one will go to here. Okay, and as long as you have one complete cycle, you're fine. And so that's our other phase shift graph. All right, and then do I have any shifts up and down? Okay, no, for our last examples, we're going to do all of them. So you're going to have an amplitude change, a period change, a phase shift, and a vertical shift. Very exciting stuff. All right, and this is our last example. So here we have a sine graph. Again, we're very boring / methodical. We're going to start the same way every time. And my amplitude actually didn't change here. I'm still 1 and -1. Wow, that -1 is pretty far down there. I'm going to put it in the same spot. Okay, but the negative will reflect me over, well, let's put in my zeros because those won't change. So sine is 0 at the pi's. So I'm putting in my zeros first. Now, originally at pi halves, I would be +1, but my negative in front is reflecting me over the x-axis. Okay, so let's put in this dotted original sine graph. Okay, this is not going to be our final answer, but I have reflected it, okay, and that's all I've done. And I've done the sine graph. But now I'm going to adjust for the period. So to adjust for the period, my period will be 2 pi divided by pi. So my new period is 2. So this, I divided by pi. So my action is to take all of my x-axis labels and divide those by pi. And so this will simplify to 2, 1, -1, and -2. So I'm at 2, 1, -1, and -2. I'm going to put those in blue. I feel like you can't really see them. So this tick is at 1, that's at 2, -1, and -2. All right, so now we've adjusted for the period as well. And now we have to shift. So we are going to have a phase shift. We're going to go left, pi over pi, which is 1. Right, so this amount is the original pi, and then you divide by your b. So I'm going to go left 1, but I'm also going to go up 3. Oh boy. So let's move. We're going to have to go up 3. And so if this is at 1, let's make this 2, 3, 4. I wonder if I can, well, that's a little different. I'm going to try to move some things out of the way here. No, you stay here. Okay, and then let's move my graph. So we're moving left 1 and up 3. And am I out of cluster? We'll do that in green. So I'm going to take this point. Let's start with this 0, 0 point. If I go left 1, that's going to move it over to here, left 1, and then up 3, 1, 2, 3. And in fact, one of the things that's easy to do is you see this original x-axis. Let's just go ahead and put that up here at 3, because everything's going to shift up 3. And if you move that up 3, it's going to make finding your zeros easier. So let's go ahead and notice my zeros are actually all going to stay the same, aren't they? Because when I go left 1, I just overlap over top of another 0. but I want left one. So, all right, and then this extreme here. So the next point I'm going to do this in purple. This extreme point right here, it was at a half 1. It's now going to move left 1 to negative 1.5, and then up 3 to 4. So it was here. I need to move it left 1, and then it totally moved a total distance of up 4. Okay, and now once you've got this, it's probably going to really help you figure out the rest of the graph, because you know where one of them went. And let me just show you one other. We'll do this one in yellow. Let's show you where this other extreme went. It was at a half, negative 1. It will move left to negative a half, and then up to 2. And so that's here. All right, and so that purple graph up there is my final graph. All right, this one I'm going to leave for you to do. Okay, practice at it and see how it goes. I think you're going to be just fine.